Hello everyone, my name is Konstantin and I'm from the University of Würzburg in Germany. In deep metric learning, we train a deep neural network to represent images as vectors, such that images that are deemed similar given a certain similarity notion are closer together in embedding space than dissimilar images. Here, for example, two images are similar if they show the same car model. However, users of deep metric learning systems, for example in visual search and item retrieval, might have different similarity notions. For example, the car color could be more important to them. To adapt deep metric learning models to new similarity notions, we would need to collect and label training data to fine-tune these models, which is costly and not user-friendly. We thus propose a new task called language-guided zero-shot deep metric learning, where the user can adapt the representation space to their own similarity notion using only natural language and no training images. To this end, we propose InDiReCT, which achieves this by using CLIP, the popular multimodal model by OpenAI. The basic idea of InDiReCT relies on the assumption that the text and image embedding spaces of CLIP are somehow aligned. When varying a certain aspect in the text, for example the color, and the same aspect in the image, this should induce variances in the same dimensions in this joint embedding space. We used this idea in InDiReCT. During training, we let the user specify text prompts that only varies the aspects of their desired similarity notion. So, for example, to describe the car color similarity notion, the user creates prompts such as a red car, a green car, and so on. We feed these prompts through a frozen CLIP text encoder. Since only the color aspect is changed, the embeddings should have variance in certain dimensions that encode the car color similarity notion. We want to keep these dimensions and discard others. For this, we apply a custom dimensionality reduction method to CLIP's text embeddings. Now, given the assumption that text and image representation spaces vary in the same directions when the same aspects are changed, we can apply the trained dimensionality reduction to CLIP image representations to focus on the desired similarity notion. During inference, we thus feed the images to CLIP's image encoder and the trained dimensionality reduction, and the resulting embeddings from that focus on the custom similarity notion. We conduct experiments on 5 datasets and overall 13 similarity notions. The results show that our model mostly outperforms CLIP's raw representations and other simple and more complex baselines. We also show that the model can approach fully supervised models. We also perform plenty of analyses to better understand InDiReCT. For example, we show that the model focuses on important image regions depending on the similarity notion. We also investigate the effects of different embedding sizes, CLIP model sizes, and number of prompts. You can find more information in our paper, and I'm happy to discuss our work during the poster session. Thank you.